Thank you, everybody over here. My name is Engineer Mari. Welcome to Mari Electronics. Don't forget to subscribe, comment, and like on my YouTube account. Today, I have a special presentation to you. This kind of presentation is all about electronics point of view. This is called Heatsink. Heatsink is like this. You see. Before continuing. Let me give my large shout out to my friends from Germany, my friends also from Canada, South Africa, Nigeria. A friend of mine called the Georgie. He's a Nigerian. Also friends of mine from USA and China. But before continuing, let me give short descriptions about our topic of today. This is called about heatsink. Heatsink is like this you see. This is an electronic point of view. Heatsink, in case by definitions, heatsink is the passive heat exchanger device that transfer the heat generated by electronics or mechanical device to a fluid medium or often air or liquid coolant. This can be most applied in most of electronics devices, as you see. For example, here I have the power supply. This power supply comprises the different components, as you see. There's capacitors, there's the transistors, and also there's the special device like this. You see, this is a heatsink. This is a heatsink. Have the power supply. Like this you see. Here we have heatsink colored black. Here this is also a heatsink. This is also a heatsink. So naturally, what is heatsink in generally? And also I have another power supply of mine. Is this one also comprises these devices? Is this one, this one, this one. There's another one here. There's another one here. Also, all of them also called heatsink. Heatsink is special electronic device like this you see. As I said, heatsink, this is a passive, heat exchanger that is transferred the heat generated by electronics or mechanical device to a fluid medium, often air or liquid coolant, where the dissipation is away of these devices. They allow the generating or regulation of the temperature. For example, here I have the device, electronic device. This is called a transistor. There is a base, emitter, and collector. This device, when there is in operation, it generates more heat within. So we fix the heat sink with this one so that to absorb the amount of the heat generated by this one, and the heat sink operating in absorbing the amount of the temperature and dissipating away to the surroundings or other mediums. In computer also we have the device like this you see, heatsink. The heatsink are used to cooling the CPUs or GPUs and some chipsets or random access memory. This one have a lot of advantages. Heatsink are usually also with the high power semiconductor devices. For example, of power transistor. Power transistor, as you see, this one is a power transistor because have the three terminals. There's a emitter, there's a base, there's also collector. Power transistors, as you can see in this another power supply. This one also. This also is a power transistor. This is a power transistor. This is a power transistor. I have another power transistor, as you see here. This one also is a power transistor, power transistor, power transistor. All of these are semiconductor materials. Also are configured with the heatsink so that to increase the performance operations of this one. Without heatsink like this you see, this power transistor operating with a lower efficiency. So we need the heatsink so that to increase the performance efficiency of the power semiconductor devices like this you see a transistor here. Also, for the case of heatsink, as we said, are used with the high power transistors. Also, there's another, the device is called, as I remember, is called optoelectronics. For example, laser lights. For example, laser lights also is configured with this heatsink. There's also lighting emitting diodes, LEDs, where the heatsink dissipation abilities of the component itself is sufficient to modulate its temperature. So this one, the main function of this one is for the to modulate the temperature, the operating temperature of semiconducting device like this we see. Heatsink is designed to maximize surface areas to contact with the cooling mediums. This one is designed also for the case of maximizing a surface area. For example, this we see have a small area, So when we configure with this heatsink, we maximize the surface area for the proper operation of these electronic devices. Then, for example, in case of air velocities, choice of the materials, protection designs, and surface treatments are factors that are affecting the performance of a heatsink, as you can see here. Here I have a lot of the power supply. You see, there's other chips. For example, this one doesn't have the heatsink. This is because itself can operate with high maximum efficient without generating high temperature. But for the high power transistors you see here, we must configure this heatsink so that to maximize the surface area and increasing the efficiency of this one. For example, also in case of the cooling of the semiconductor device like this one, also we can use the thermoadhesive or maybe thermal grease. You see, this is white, this is the thermoadhesive. Also, we can also fix the materials, for example grease, so that to increase the physical contact between the semiconductor materials, like this you see, and the heatsink, as you see here. Heatsink most of times can be constructed with the copper or aluminum. In both cases, the main aim is for the case of increasing the performance of electronic devices and avoiding burning away of this one. So as you see, most of the high power transistors, as you see here, let me do this. Power transistor, as you see, this is a high power transistor. We must configure with this one heatsink so that to increase the performance of this one. So in my next video, I can teach you and give a lesson how the transferring of the heating from the semiconductor device like this one is conducted naturally. So thank you very much for your attention. Don't forget to subscribe in my YouTube account called Mari Electronics. Subscribe, comment, and like. Thank you very much, and welcome to my next video or next week. Or next week. Thank you very much for your attention.